Hi and welcome. So this time around I've just got some interesting tools I've acquired and some mods I'm making to my surface grinder. So let's just get started. So people are probably familiar with a 5C emergency collet. Typical, this is a pretty big one, and they just bored it out to fit whatever part they wanted in here, and then when you tighten it down it grabs from three directions. Pretty handy. You put pins in here while you're tightening this down to do the cut, and then you pull the pins out when you're done, and then this thing can close down and tighten a little bit. This is a standard 5C emergency collet, and I'm sure a lot of you have seen this. What's interesting was not this, was this set of 5C emergency collets where the leaves are replaceable on it. So they're bolted through with 1/4-20s, and you can replace the aluminum pieces with anything you want, which is kind of neat. I've never seen one like this. I actually got two of these in a lot. These are all used ones, came with a bunch more of those. These are what I really wanted because I've never seen anything like it and seemed like they'd be pretty useful, because rather than throw it out when you're done, you just make some new aluminum pieces. So those are kind of neat. Next up was an eBay find, and I've been looking for one of these NSK grinders, air grinders. I actually want an electric one like Stefan Gottswinter has, but can't really afford one of those new, and they don't seem to come around used very often. So I bought this one for $100, and it was supposedly working. When I got it, it was completely frozen. The shaft wouldn't turn at all. So I sent it back to, and the seller didn't want it back. So what I did was I sent it back to NSK for evaluation, how much it would be to repair, and it was really expensive, but they promised to make it like brand new. I mean, other than some cosmetic stuff on the outside here. So they basically replaced all the inside parts on it entirely, and I ended up with essentially a brand new one, for about half the price of brand new. So a new one of these is something over $600, and the repairs were $300 and a little over $300, like $320. So what's really interesting, this is a 60,000 RPM air die grinder, and with this muffler on it, it's surprisingly quiet. So I got this guy to do some deburring. It has an 1/8" collet in it, and you control the speed on the base right here. Surprisingly quiet, right? Next up is this Sjogren Hardinge 5C speed chuck, and the guy who shipped it to me didn't know much about it, and so to send it to me in a small enough box, he took it apart rather than just pop the D6 mounting bolts off here. He actually disassembled it. So I've got to as long as I've got it, it came shipped sort of like this with these two gears sitting here like this. So as long as I've got it apart, I might as well clean it up. This one's different than some of the other ones of theirs I looked at, in that right here, instead of this felt bit, they had, the other versions had a thrust bearing in there, and maybe this is just a less expensive version of those, but this one doesn't have that. And I don't think it's missing because, again, it looks like the felt just mates up inside there, and it looks like he uses oil lube on this rather than grease, which I also find interesting. Typically things like this are greased, not lubed. So the gears are all hardened. This one has one gear pressed into the other gear, which is kind of interesting, rather than cut them, together in some sort of kludgy fashion. They made nice hardened gears and then pressed them together. It's kind of neat. These guys seat up here, which mate with this plate, and you can see it rotates. It's very smooth. And then that goes to the collet nut. Here's the 5C, grabs the back of the 5C collet here. And that bit goes in here, like so. So then when you rotate this, you can tighten the 5C collet with just the rubberized handle here, which is kind of neat. It might be a more precise version that they've got that that replaces this felt with thrust bearings, because the felt mates back here on this side, and on the front the felt rubs against the hardened and machined surface there, which interestingly enough, so if we flip this guy over, let me take these guys out of here, set them here. If I flip this over, that whole assembly was pressed in. See that? Kind of interesting. So they hardened it and then pressed it in. So I guess they machined it carefully and then assembled it like that. I'm guessing it's machine. I guess I don't know for certain. It could be some threads there in the corner. I'm not sure. And instead of a grease zerk, this one has an oil ball in it. So I guess they intended to be working with oil. So I'm going to pop this guy back together with some Vactra, and we'll give it a shot. I use this on my lathe. Let me show you what I had before. So this was my inexpensive 5C collet holder that I got a long time ago, and I've been using that, and it works fine. But I'm not as happy with it. It's kind of bulky and sticks out a lot, and there's a lot of slop in the scroll in this guy, so that's also not very nice. So I figured the Hardinge would probably be better, and I got a reasonable deal on it, brand new. The ones with the bearings cost about $2,000. I don't know if there's a felt version they still sell. Their website's a little hard to follow, but in any case, I still think this will be better than this. Like I said, not terribly happy with this one. Everything appears to be in really good shape. There is a little bit of goop down in the holes where the pins are riding. I noticed they put some oil channels so that oil could get around from the zerk fitting. That was really nice. Actually did a pretty good job of that. Looks like originally this might have been assembled with grease, but that fitting on the front is an oil well, so I'm kind of curious about that. So clean this up, and we'll take the excess off after. I'm using some Vactra that I use on my mill. So yes, yeah, one side of this is finished, the other side not, so I'm guessing it goes this way first. That's nice and smooth. Just run that oil in, and oh, I don't think it touches here, but just in case, it doesn't look like it rubs there at all. This thing's in really good condition, or appears to be anyways. I did notice there was some sort of scratch here. Something happened that wasn't pretty at some point in time. Oh, these gears going first. Got it. Okay. I only did a little bit of cleaning off camera. Mostly this thing was in great shape, like I was saying. Pretty clean inside. Okay, that's pretty smooth. So I will just add a little bit of grease around here, lube around here, and a little more around here. Line these pins up. Nice and smooth. Flip it 180 and put the 4 Allen bolts in that it came with. Uh-oh. I don't think I'm quite seated all the way here. So it does register on this inside carefully machined boss, and there's some grit in there, little chunks of metal, so perhaps that's what's fighting this thing sitting flush. and it was a precision fit. I'm going to deburr it here because yeah, someone got in there with something they shouldn't have. Be right back. So after I deburred it, it still was a fairly tight fit. This is very clearly a precision machined assembly here. So I then used the bolts here to slowly work my way in and tighten all the way around. And I think there is going to be no needing to knock this around to center, because it is, I might be wrong about that, but it is really an accurate fit. It's almost a press fit. It's really, really tight. So there was no way I was going to get it together before I deburred it, because the guy had popped a screwdriver in there and had really turned up some nasty burrs. But here we are together. No more slop. Very nice. I'm going to load this full of oil and we should be good to go. Another thing, which I thought was sort of standardized, which is kind of weird, but the D16 slot positions here aren't lining up. So the way you do that to fix that is you remove the locking screws, which are feeling really crunchy, so I guess it's good that I'm popping it out. And then you can go full revolutions to go to the next depth setting. So I'll try this on my my lathe rather. If it works right, then we'll be good to go. And that's just the game. You basically thread these guys in. They've got to end with the notch on the inside, and you pop a screw in and lock it down once it's tight. This here is machined really closely as well. It's an excellent fit. So interesting observation, compared to the lathe it was on previously, it took 2 complete revolutions of the locking studs to get it lined up right for mine, which I think is kind of interesting. I thought the standards were closer to that. I know they've made these adjustable on purpose, but I would have thought there would have been some sort of standard associated with them. And here's the 5C collet chuck, and you line the slot up, which it actually says key is there, and then you just run it in. And it takes a little bit of time to run that all the way in. So if you're changing 5C collets out a lot, it's going to take you a bit of time. And the 5C collet sticks out a little proud of this, which probably was not an accident. It lets you get a tool really close to the collet itself here. So there you go. That's all the way in where it's starting to get tight. And now it's engaging. And that's it. Alrighty, let's move on to the next thing. All right, we're over here at the surface grinder, and we need to do 2 things. One is with the involving the DRO, and the other is involving the cutting fluid. And right now it's a little low in the tank. So I have a bubbler in there that keeps it aerated, but you still need to check the concentration. So the way you do that is with a refractometer. And inside it's very temperature sensitive. So inside the refractometer is a bimetal strip that compensates for temperature. But then you take a drop of distilled water, put it in there, and make this adjustment so that the line, when you're looking through, the liquid will have create a sharp line for a fluid like distilled water, and you set that on 0. Then you take a dab of your cutting fluid, put it on here, close this down, which makes a very thin film out of it, and then you look in here, and what you end up seeing is a line of demarcation. And if it's a hard line, then you know that your solution, among other things, does not have a lot of other things in it other than just the dissolved cutting fluid and the water. So in my case, it's currently sitting at about 12%. And on the side of your container with the paperwork, it'll give a multiplier for the value you read in here and what it's supposed to be. Mine, fortunately, is multiplied by 1, so it means I've got 11%. But some of them are like 1.1, 1.2. So if this was 10 and it was 1.2, you'd actually have 12%. Anyways, so I'm shooting for between 5 and 10%, so I need to add some distilled water to the solution. My air pump came with air stones, but the cutting fluid, the concentrated cutting fluid stuff, it dissolved the stones and completely disintegrated them. So the air stones weren't working. So instead, I'm using these drip drip line adapters. This is a 1/2 gallon per hour, 1 gallon per hour, 2 gallon per hour drip adapters, and they seem to work great for the air. And so far, the cutting fluid hasn't attacked them. So that's my solution if you want an inexpensive one. Next up, which I periodically run the fluid through a filter bag. I have one down in the sump as well. The tube goes into a filter bag, but I figure I'll double filter while I'm aerating. So I run the fluid through this, even though there's a bubbler down there, periodically when I'm out here and I have the 3-phase on, I just run the fluid through a bag, which aerates the daylights out of it. My next problem is dealing with this DRO. So it's actually pretty dark right now. It's like 4 or 5 in the evening, and you can see how hard it is to read that display. LED displays are typically multiplex, which means each segment that's on gets turned on in turn and then off again. And they do it so quickly that persistence of vision makes it so that you see what looks like a continuous character. To make it brighter, you can either increase the current, so for the period of time it's on, you put more current so it's brighter, or you can hit it more times per second, which will make your eye think it's brighter. But in either case, this one has no adjustments. I could take it apart and modify the circuitry, but I thought about getting another DRO because I wanted to check it out anyways. And it was only 100 and something bucks, so I'm going to put that in and let you take a look at that. All right, so here's the new DRO installed. And this is a 3-axis one. I figured for the extra $10, why not get the extra axis? That way, since if you buy 2-axis, it's XY, what I really wanted was YZ because the first control Y is right here, and the height, Z, is right here. And it's currently reading in 1/2 tenths, which is what the resolution of the scales are. These are 1 micron scales, and you can zero them. It's pretty handy. So they're compatible with the scales, all is good, and this will be much, much easier to read than the previous DRO. I can read this from any angle. If the sun's up, I can still read it, which was a huge problem. So very exciting. This is a huge improvement for about 120 bucks. I got mine on Banggood, but I'd recommend going to AliExpress. They also have it. Banggood, I've had some serious customer service issues with things that I've bought, and so I am no longer reviewing their items because their customer service isn't any good. So anyways, that's about it. I hope you found my little projects around the job interesting. I know none of them were, epic or anything like that, but they're all useful, and hope you find some of them interesting. Thanks for watching. Hope to see you next time.